Alright, so in this video I wanted to talk about friction on flat surfaces. So there's only really one equation that's relevant here, which is that the frictional force equals the coefficient of friction times the normal force. So I have a practice problem I wanted to run through real quick. So we have this block that's 100 pounds, and it's on this inclined slope here. We're given the coefficient of friction is 0.25, and we want to find the angle theta at which the block slips. So let's start off by drawing a free body diagram of what we got going on here. So we have the gravitational force, which is going to be going straight down. So that's just the weight, which is 100 pounds. But then we also have what I'm going to call the x and y components of this, because when we change this angle, you can also rotate the coordinate system so to line up with it. So that's your new x and y, just to make things easier. So we have our weight, and then we have, we're going to call this the y component, and then our x component. And then this angle here is also going to be theta. So those are the same. Now, since we have inclined this now, we also have a friction force. And that's resisting sliding. And so if this was laying flat, you would have a friction force if you were pulling on the block, but if the block was just sitting there and no load was applied to try to get it to slide, then you would not have friction, because the friction has a maximum value. So on a flat surface, if you were asked, like, what force does it take to get the box to slide, your friction force would actually increase up until your friction force equals F. But it starts at 0. So if F is 0, friction force is going to be 0. Then as F increases, your friction force increases up to F equals your coefficient of friction times your normal force, which would just be your weight. Alright, so back to this problem. Let me label this as friction. So this is actually a pretty straightforward problem. So we want our friction force to equal our x components of the weight, basically. And that's going to keep it from sliding. So the friction force is equal to weight in the x direction. So kind of breaking these apart, friction is your coefficient of friction times the normal force, which is Wy. And then Wx is equal to the weight times the sine of theta. And then along those lines as well, our Wy is going to be W cosine theta. So kind of putting that all together, we have the U times the weight times the cosine theta equals the weight times the sine of theta. So the weight is going to drop out. Now we're left with mu equals the sine of theta divided by the cosine theta, which is the tangent of theta. So our theta just equals the arctan or inverse tan, whichever you prefer, of mu, which is arctan of 0.25. So our theta is going to be 14.04 degrees. So this is the angle. Once you get to this angle, or once you get above this angle, the block is going to start to slide down. So you can see that the theta is related to the coefficient of friction with the tangent. So this is a good equation to have memorized, is that the tangent of theta equals mu for a block on an inclined plane. But yeah, that's kind of all I wanted to do in this video. I hope that helps.